So good morning class. Today we will discuss about the next type of bonding, that is hydrogen bonding. In the last segments we discussed about ionic bonding, covalent bonding, coordinate bonding, and we saw the formation of hydronium ion and ammonium ions, that was examples of coordinate bonding. So in today's lecture we will discuss about hydrogen bonding, and the hydrogen bonding further we will see of two types, that is intermolecular and intramolecular. So we will discuss about them in detail. So very first we have to discuss about hydrogen bonding. So we have to discuss about hydrogen bonding. So as the name suggests, there is hydrogen atom, and that hydrogen atom will exist in the form of hydrogen bonding to the more electronegative atom of a covalent bond. So this is the basic criteria for hydrogen bonding. There is a covalent bond, normal covalent bond, and the more electronegative atom of that covalent bond will be linked through hydrogen bonding to the next covalent bond. So this series continues and leads to the formation of hydrogen bonding. So further, this hydrogen bonding is of two types. This is intermolecular hydrogen bonding and intramolecular hydrogen bonding. They are of two types, intermolecular and intramolecular. So let us first take a very simple example of hydrogen bonding to study what is hydrogen bonding and how it can be formed. So the very first example of hydrogen bonding was found in HF. HF, hydrogen fluoride or hydrofluoric acid. So when we discuss about HF, that is HF molecule, so this HF molecule doesn't exist in the form of one molecule, two molecule, three molecule, but it exists in the form of cluster of n number of molecules. So this HF exists in the form of HFN, where n can be any positive integer like 1, 2, 3, 4, it can be any. There is no fixed value of n for in case of HF molecule. So let us discuss how HF molecule will be existing or how it will be formed. So let us take a simple example of HF, this one. So we know this is a simple covalent bond between one hydrogen atom and one fluorine atom. So the more electronegative atom, this is our more electronegative atom, will be hydrogen bonded to the next HF molecule. So this is our next HF molecule. Again this process will continue. This is our hydrogen bonding shown by dotted line, and this is our again next HF molecule. The same process will be extending this side also. And so on, this process will follow in both the sides, and this will exist in the form of n, where n can be value of any positive integer. So this, which is shown by dotted line, this is our hydrogen bonding. This is our hydrogen bonding, and to be more precise, this is an example of intermolecular hydrogen bonding. This is an example of intermolecular hydrogen bonding. So let us see once again the case of HF molecule or HF atom. So in case of HF, it doesn't exist in the form of one molecule or two molecule, but it exists in the form of n number of molecules, where n can be any positive integer. Now let us see what is the basic criteria for the formation of hydrogen bonding. In case of hydrogen bonding, the more electronegative atom will form a hydrogen bonding with the hydrogen atom. Like we are taking the example of HF molecule. So in case of HF molecule, the more electronegative fluorine atom will form a hydrogen bonding with hydrogen atom of the next HF molecule. This is our next HF molecule. Now again the more electronegative fluorine atom will form a hydrogen bonding with the hydrogen atom of the next HF molecule. Again the more electronegative fluorine atom will form a intermolecular hydrogen bonding with the hydrogen atom of the next HF molecule, and this process will continue on both the sides, and this series will go to a length of or to an extent of n, where n can be any positive integer. So this is the first example in which hydrogen bonding was discovered. That was the example of HF molecule, where HF molecule doesn't exist in the form of monomer, dimer or trimer, but it exists in the form of polymer, where different HF units are linked through hydrogen bonding, and this is our normal covalent bonding. So now let us discuss further what are the different examples of intermolecular and intramolecular hydrogen bonding. So this was the example of intermolecular hydrogen bonding. Now let us discuss what are the two types of hydrogen bonding. That is, first one, intermolecular hydrogen bonding. Intermolecular hydrogen bonding. So what is intermolecular hydrogen bonding? Intermolecular means when the hydrogen bonding exists between the atoms of different molecules. ये अलग अलग मॉलिक्यूल्स के बीच में या अलग अलग मॉलिक्यूल्स के एटम्स के बीच में जो फोर्स काम करता है, जो बॉन्ड काम करता है, उसे कहते हैं इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग. So the bonding which exists between different atoms of different molecules, that type of hydrogen bonding is called intermolecular hydrogen bonding. Like for example of intermolecular hydrogen bonding is, for example, water, NH3, ammonia, HF, etc. These are some of the examples of molecules which possess intermolecular hydrogen bonding. Now, let us see the example of water, H2O. When we are discussing about the case of water, we know that water possesses bent shape. This is our one water molecule, first water molecule. Since oxygen is more electronegative as compared to both the hydrogen atoms, so this oxygen will form hydrogen bonding, which is represented by dotted lines, and it will be connected to the hydrogen atom of the next water molecule. So this is our hydrogen. It will be further linked to oxygen atom, and this will be further linked to hydrogen atom. And the same thing will happen this side. Hydrogen, oxygen, hydrogen. This chain will further extend in both the sides. Both the sides it will extend and will further lead to a chain reaction constituting different particles. So this is our hydrogen atom linked to oxygen, linked to hydrogen. This is our hydrogen atom further linked to oxygen, further linked to hydrogen. This is linked to hydrogen, oxygen, hydrogen, hydrogen, oxygen, hydrogen. And this chain reaction will continue in the same way and leads to the further attachment of different water molecules, different water units. So this process will continue, and this dotted lines represent intermolecular hydrogen bonding. These dotted lines represent intermolecular hydrogen bonding. So again, let us discuss what is intermolecular hydrogen bonding. When the hydrogen bonding exists between two different atoms of two different molecules, when the molecules differ, this type of bonding is called intermolecular hydrogen bonding. Inter means between and molecular means between two molecules. When the hydrogen bonding is formed between two different molecules, it is called intermolecular hydrogen bonding. For example, water, ammonia, HF, etc. So when we are discussing about water, this is our water molecule. So let us start from the first. This is our first water molecule. Oxygen being more electronegative will be linked to hydrogen of the second water molecule, and again this oxygen will be linked to hydrogen of the third water molecule. Now this will be further linked to this water molecule, and this oxygen will be further linked to this water molecule. Now this will further extend to further attachment of water molecule with this carbon oxygen atom, and this oxygen will be further linked to this water molecule. This chain reaction will go on and leads to the further attachment of different water molecules, leading to the formation of intermolecular hydrogen bonding. So this was our first example of water, wherein we discussed about formation of intermolecular hydrogen bonding. So let us discuss our next example, that is formation of intermolecular hydrogen bonding in ammonia, NH3. So in this case, we may say that this is our first water molecule, this is our second water molecule, this is our third water molecule, this is our fourth water molecule, this is our fifth water molecule, sixth water molecule, and seventh water molecule, and this chain reaction will go on. The next example we will consider of ammonia, NH3. So in case of ammonia, we have a nitrogen atom, and nitrogen atom is linked to three hydrogen atoms, and this nitrogen being more electronegative will be further linked to hydrogen, and this be further linked to nitrogen, hydrogen, hydrogen, again linked to nitrogen, hydrogen, hydrogen, hydrogen. Again this molecule will be linked in the similar manner. And this process of continuation will go on both the sides. And these dotted lines represent formation of intermolecular hydrogen bonding in ammonia, and this is the case of ammonia. So we discussed about intermolecular hydrogen bonding. Intermolecular hydrogen bonding is the type of bonding in which hydrogen bonding is present between different atoms of two different molecules. For example, this hydrogen bonding, intermolecular hydrogen bonding, is present in water, it is present in ammonia, and we already discussed one example of intermolecular hydrogen bonding, that was the case with HF, hydrofluoric acid. So in case of water molecule, this oxygen atom linked by intermolecular hydrogen bonding to next water molecule, this oxygen atom further linked to this water molecule by intermolecular hydrogen bonding. Further, this extension of intermolecular hydrogen bonding and this linkage of different water molecules will continue in the same manner and lead to the formation of a chain of water molecules, wherein different chains of water molecules are linked by these intermolecular hydrogen bondings. So the next example was of ammonia. In case of ammonia, the more electronegative nitrogen atom will be linked through intermolecular hydrogen bonding to the hydrogen of the next ammonia molecule. So this is hydrogen of the next water molecule. So this is our second ammonia molecule, and again the nitrogen atom of the second ammonia molecule will be linked to one hydrogen of the third ammonia molecule, and again the nitrogen atom of the third ammonia molecule will be linked by intermolecular hydrogen bonding to the one hydrogen of fourth ammonia molecule, and this process will continue in the same manner, and this chain reaction will go on, leading to the further attachment of different types of ammonia molecules. And again, let us see the example of HF, which we saw earlier. It also has intermolecular hydrogen bonding. So in case of HF, when we earlier also we discussed, we have a molecule of HF. Fluorine, being more electronegative, will be linked by intermolecular hydrogen bonding to the next molecule of H through hydrogen atom. Again, this fluorine atom, being more electronegative, will be linked by intermolecular hydrogen bonding to the hydrogen atom of the next HF molecule. Say the same thing will happen this side also. This will be linked to the another HF molecule, and this pattern will follow on and leads to the formation of a cluster of HF wherein they exist as a polymer, wherein they have different units of HF molecule, and that's why we have written N, where N can have any positive integer 1, 2, 3, 4. That's why HF molecule doesn't exist in the form of monomer, neither in the form of dimer, trimer, but it exists in the form of polymer, where the value of poly will depend on the value of N. Whatever will be the value of N, that much units will be found in the molecule of HF. So, thank you guys.